Hello, and welcome to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I'd like to introduce KYZEN's own Andreas Dorn.
Thanks, William, and welcome everyone. My name is Andreas Dorn, and I'm the Regional Manager for the KYZEN Corporation in Northern Europe. Today, I will talk about why isopropyl alcohol, or IPA, is not the best choice for cleaning in electronics manufacturing. While it is widely used, there are several drawbacks that make it less effective and even problematic in certain situations. Let's explore the issues in detail. Let's start with some key points. Cleaning is a critical step in electronics manufacturing. Contaminants such as flux residues, dust, and grease can affect performance and reliability. IPA is commonly used because it is widely available, dries quickly, and is relatively inexpensive. However, despite its popularity, it has several limitations that make it a less than ideal choice for cleaning electronic components. In this presentation, we will examine these issues and explore better alternatives. Let's talk about some common uses of IPA in electronics manufacturing. IPA is used for various cleaning tasks in electronic manufacturing. It is often used to remove flux residues after soldering, clean printed circuit boards (PCBs), and connectors and prepare surfaces before coating or bonding. While it seems like a convenient solution, its effectiveness is limited in several ways. Now let's talk about the limitations of IPA. One of the main problems with IPA is that it is not effective against all types of contaminants. While it removes some flux residues and oils, it struggles with stubborn residues, ionic contaminants, and certain adhesives. Another issue is that IPA evaporates very quickly. While this might seem beneficial, it can actually reduce its cleaning efficiency as it does not allow enough time to dissolve contaminants properly. Additionally, IPA can leave residues behind, which may attract moisture and cause further contamination. Here on this slide, you can see the comparison between IPA and engineered solvents and its pros and cons. Also on the bottom of the slide, you can see the comparison between IPA and engineered solvents if it comes to removing of flux residues. Now let's talk about material compatibility issues. IPA is not suitable for all materials. It can damage certain plastics, coatings, and adhesives used in electronic assemblies. Some material may swell, crack, or degrade over time when exposed to IPA. This makes it a risky choice, especially when working with delicate or high-value components. Now let's talk about the safety and environmental concerns with IPA. Apart from its cleaning limitations, IPA also presents safety and environmental concerns. It is highly flammable, it has a flash point of 12 degrees C, which increases the risk of fire hazards in manufacturing environments. Prolonged exposure can also cause skin irritation and respiratory issues for workers. Furthermore, improper disposal of IPA can lead to environmental pollution, making it less sustainable compared to alternative cleaning methods. You can also see on the chart on the right side where IPA is compared to stencil cleaning agents. Now let's come to the alternatives of IPA. Fortunately, there are better alternatives to IPA for electronics cleaning. Water-based cleaning solutions, for example, can be more effective at removing stubborn residues or residues in general and are safer for the environment. Specialized electronic cleaning solvents are designed to target specific contaminants without damaging sensitive materials. Additionally, ultrasonic cleaning with deionized water provides a highly efficient residue-free cleaning process without the risks associated to IPA. Now we come to the point of the cost and efficiency comparison. When comparing IPA to alternative cleaning solutions, the alternatives have an impact on the yield in your production and also on the defect components that you do not have to do rework on. The cost effectiveness might not be as obvious at first glance. While IPA is cheap upfront, its inefficiency can lead to higher rework rates, product failures, and long-term costs. Alternatives, such as water-based cleaners or ultrasonic cleaning, might have a higher initial investment but offer better cleaning results, improved reliability, and reduced safety risk, ultimately leading to cost savings in the long run. This can also be seen in the chart on the right, where the overall costs in a production with 11 SMT lines were compared between IPA and a cleaning solvent as an example. Now we come to our conclusion. To summarize, IPA is not the best choice for cleaning electronics manufacturing due to its limited effectiveness, material compatibility issues, safety hazards, and environmental concerns. While it is widely used, better alternatives are available that provide more reliable and safer cleaning solutions. Companies should consider switching to water-based cleaners, specialized solvents, or ultrasonic cleaning to improve product quality and workplace safety. Here are some frequently asked questions to this topic. First question: does IPA cause damage to plastic components? Yes. IPA can degrade certain plastics and rubber components over time, causing brittleness, cracking, or discoloration. Question number 2. Can IPA cause corrosion on electronic components? While IPA itself is not highly corrosive, it can displace moisture which, if not properly dried, may lead to oxidation or corrosion on exposed metal components. Question number 3. Is IPA effective at removing flux from soldering? IPA can dissolve some types of fluxes, but it may not completely remove rosin-based or no-clean fluxes, often requiring additional cleaning steps. And the last question: does IPA evaporate too quickly for proper cleaning? Yes, its fast evaporation rate can sometimes cause residues to redeposit before they can be wiped away, leading to ineffective cleaning. Thank you guys for tuning in into this presentation, and take care.
Thanks, Andreas. And thank you guys for tuning in to this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.